All right, so chapter 4 has a lot of odds and ends and just kind of disconnected things, and we're going to try and work through as many of them as we can. So what I want you, well, first of all, just a reminder, you should be reading in chapter 4. We started talking about balancing equations on Wednesday and transcribing equations on Wednesday. And we just touched on reaction types. So we're going to do some more reaction types today. You need to finish vocabulary 4 by Sunday. You should have already finished prepare to learn 4A. If you haven't done that, you need to do that. And then also due on Sunday is homework 10 on active chemistry and homework 11 on active chemistry. For freshmen, next week is when we do our academic progress checks. That is a way for us to let you know if we think that you are stumbling enough that this could prevent you from achieving a successful grade in the class. You may want to, if you have intentions of being successful in this class, make sure that you've gone and finished your homework assignments and gotten things turned in. So that it looks to me like you're actually planning on being successful. Most people are in that situation, and so that's fine. But if you have things that are missing, make sure that you finish those. Is this a hand raised over here? Or no? Okay. And yeah, so there's that. The academic progress check is really just that. It's a progress check. You know the grades that you have. I know the grades that you have. So it doesn't really change anything. It's not like I'm tattling on you or something else additionally bad happens. It's just a communication thing. So in case you thought, oh yeah, I'm doing fine in this class, the progress check is kind of that way of letting you know, oh, maybe I need to check in on things. Okay. And then you have a homework assignment that is due on Tuesday that is on reaction types, and we're working our way through those reaction types. You have in your folder 4 copies of some practice of various types of problems. So each of you gets a copy of that. But I have selected some that I want you as a group to turn in. So while I'm taking attendance, what I'd like you to do is decide who's going to play what role. Your manager's keeping you on track. The recorder's the one who actually has the paper in front of them. When I make copies, the recorder gets the original copy. Spokesperson can tell me what your group is thinking or come to me and ask questions. And your strategy analyst is the one who's going to say, hey, manager, you're talking too much, or hey, Susie Q, you haven't said anything. You need to be participating and can reflect back what we're doing well, what we're not. We're arguing too much, or nobody's saying anything. Somebody should say something. So those kinds of things. If you have only 3 people in your group, like this group here, one person should do both spokesperson and recorder. That should be the same person. And if you are a 2-person group, then one person should be spokesperson and recorder, and the other person should be manager and strategy. Okay. So I want you to start just on the front page. You've got 3 or 4 equations to balance, work together on those. And then you have a couple of sentences that you're going to translate into a chemical equation. I'm going to go grab my attendance. The individual sheets are for you to practice with. I'm not going to collect those for grade, but I do highly recommend that you take a look at those for practicing purposes and making sure that you understand the content before whatever quiz you might have upcoming. Probably we'll have one next week at some point. We were talking yesterday about reaction types, and I said there are a couple of different ways we can organize it. And so we started looking at it by number. So a lot of reactions, we just count how many reactants, how many products do we have, and you know, what kind of reactants and products there are. So with a double displacement, that was the first one we looked at. This is also sometimes called metathesis. This reaction is where we have two ionic or acid reactants. And then we said what we do is we swap the cations. And so for number purposes, that means we have two reactants and two products. Now there are two types of these. You saw these in lab this week. One is the neutralization. So that's where you have an acid and a base. So your acid, you're looking for an H somewhere. And for a base, almost always, it's going to be an OH. However, if you see CO3, it acts like a base, and we'll show you how to do that one in a little bit. All right, so let's do an example of this. The easy example is the one we did on Wednesday, HCl plus NaOH. Remember, our cations are the first things that are listed, so they are metals or hydrogen, and that's why hydrogen is in that column. So it's a nonmetal, but it behaves as a cation, and we're just going to swap those two. So I'm going to leave the Cl where it is, I'm going to leave the NaOH where it is, but I'm going to pull the Na to the front, and I'm going to put the H over here. So when I do that, I'm going to have NaCl, and then I could write HOH, but I'm going to put my hydrogens together. I have H2O. Okay, so I get a salt and I get water as my products. So if I have to predict what the products of my reaction are, it's helpful for me to know what kinds of chemicals I have at the beginning. Okay, so if I know that I have an acid, then I should guess that one of my products is going to be water. All right. So we could do this with other acids. So let's take nitric acid and calcium hydroxide. And remember, when you have ionic compounds, you want to check to make sure your charge is balanced. Calcium is in column 2, so it's a +2. Hydroxide has a -1 charge. So I'm going to put an OH, and I put parentheses around it so that this 2 that I put here applies to the whole thing. All right? So see if you can swap the cations and figure out what the products will be. Remember, your cations are listed first, so we're going to swap the hydrogen and then calcium. All right, so I'm going to put calcium first and then NO3, but I also have to charge balance in my products. Okay, so this wasn't a balanced equation to begin with. So calcium we said was +2. What's the charge on NO3? So if that's something you don't know, you should have out your polyatomic ion sheet while you do these things so that you can check, and then that way you can start learning, oh yeah, every time I see NO3, that's a -1. So if it's a -1, I'm going to need 2 of these, just like I did for the hydroxide. All right. And then I should have water as a product, but let me check. I've got a hydrogen here. I've got an OH here. So that gives me H2O, but this isn't balanced. Okay, the one up here just happened to balance naturally. This is not balanced. All right. So if you're trying to balance an equation and it has a polyatomic ion in it, if that polyatomic ion appears on both sides, like the nitrate does, we can kind of just consider that as one unit. We don't have to pull out the nitrogen and pull out the oxygens. we can just say there is one nitrate here and there are two nitrates here. So I'm going to put a 2 in front here. Hydroxide only appears as hydroxide on this side, so I can't do that with hydroxide. So I'm going to have to count out, okay, I have 2 oxygens and 2 hydrogens. And then here I have 2 hydrogens, so that gives me 4. Now over here I have 2 and 1, so I'm going to put a 2 in front of that, and that gives me 4 hydrogens and 2 oxygens there. Okay, and then my calciums are balanced. All right, our second kind is sometimes called a solution reaction, sometimes called a precipitation reaction. It's only interesting if we get a precipitate, so that's why we typically go with precipitation reactions, but in theory, it doesn't have to. Precipitation. So this is going to look the same, but there will be no acid. So we'll just have 2 ions. All right, so again, I'm going to swap the cations. So let's say I have barium chloride. And usually both reactants are aqueous when we do this. And I have potassium sulfate. All right, so what 2 elements are the cations? Will, do you know one of the cations? Barium, it's listed first. All right, Sam, do you know the other cation?
Potassium.
Potassium. Okay, so those are the 2 that I'm going to swap. Now, I'm not going to take the numbers when I swap because I have to charge balance. So these numbers, I'll have to refigure out what those are. But I'm going to put the potassium first, and then the chloride, and then I'm going to think, okay, potassium is a +1 because it's in column 1. Chloride, what is that one? -1 because it's in the row next to the noble gases. So do I need any subscripts for that? No, it's already balanced. And then I'm going to take the barium and put it with my second anion. Barium is what charge? +2. Sulfate.
It's -1.
It's actually -2, but thank you for playing.
Yeah.
So do I need any numbers? No, I don't need any numbers. All right, so here I don't have phases, and we haven't gotten to this yet. At this point, what we would have to do is decide, are these soluble or are they not soluble? And so it turns out this one is soluble, so it stays aqueous, and this one is not, so it becomes a solid. All right, so, but we'll get to solubility, possibly on Monday. All right, then we talked about single displacement reactions. So in this case, we are starting with 1 ionic or acid plus an element. And we're going to end up with the same things. So if I'm counting how many reactants and products I have 2 reactants and 2 products. The difference is these are both compounds, and in this case, I'm sorry, the ones that we just did in double displacement that you can't see where I'm pointing, those are both compounds. And the ones that we're talking about now, one is a compound, one is an element. All right, so we said with this one, we're going to swap the cation for the element. Okay, so in lab, you did this with an acid. So you had HCl, here's our acid, and then you tried 3 different elements. You tried copper, you tried zinc, and you tried magnesium. Which one did not work? The copper should not have worked. Copper should have pretty much just sat there, right? Magnesium should have gone to town, made all kinds of bubbles. The zinc, after a minute or so, you should start seeing bubbles on the surface. So let's try zinc. So what I'm going to do is I'm going to say, this is my cation, the hydrogen, and I'm going to swap it for the element. So I'm going to have ZnCl, but I have to pay attention to charges. So zinc is kind of a tricky one because it's not in column 1 or 2, but remember I told you these 3, aluminum, zinc, and silver, they each have a particular charge that they always are. And zinc's charge is always +2. How many chlorines do I have? 2, because chlorine is -1. Okay? And then my hydrogen is going to appear as an element. And so I have to remember that hydrogen being on that green, dark green 7 there, well, hydrogen's over by itself. It's dark green, and it's part of Brinkelhoff. That is a diatomic. Okay. Now you also did this with an ionic compound. You used copper sulfate and zinc, which we can do the same thing. The copper is an cation and the zinc is the element. So we make it zinc sulfate and copper. So those are our single displacements. Next week, you are going to do a titration with the acid-base reaction. So you'll see a neutralization one next week. Okay, now let's talk about other reaction types. Okay, so one is called it has lots of names, synthesis. That's what I usually call it. Sometimes it is called an addition. Sometimes it is called a combination. I think I've heard other names as well. Those are the most common ones. So this one is easy to identify because all of your reactants form one product. So the way you recognize this, if you're trying to identify, is there is only one product. So usually this isn't one where we say predict what the products are, because when you start with 2 reactants, you know, how would you guess that you're forming one product? Often this will happen when you have 2 elements because, you know, you can't swap partners. But that's not the only way that you might have it. So some examples of this, you had a magnesium strip and you burned that in air and you form magnesium oxide. Okay, so just one product. The opposite of that is a decomposition. This one has one reactant. And it decomposes into 2 or more. You did this one in lab a couple of weeks ago by having magnesium sulfate heptahydrate. So this is all one compound. And it decomposed into magnesium sulfate and water, which went into the air. So in this case, we are just separating two things that could by themselves exist as molecules. Sometimes when we decompose something, for example, if you take HGO, when we separate it, we form mercury metal, which is a liquid, and oxygen gas. That kind of separation, instead of forming just the compounds that we started off with, we're going to elements. And so sometimes we might want to call those by different names. And that leads us to our different system. And our different system is instead of looking at numbers, is looking at the types of chemicals. And so one of those involves our double displacement ones. Instead of grouping them together, we might say, oh, neutralization we're looking for an acid plus a base. And then precipitation, we are going from aqueous reactants to one or more solid products. But the important part about grouping it this way is looking at redox reactions, which is an abbreviation for oxidation reduction reactions. All right, so your lab instructor probably talked to you a little bit about oxidation numbers. We'll get more into this next week, but as far as identifying these, almost always, it's not necessarily true, but the ones we will look at, usually there is a pure element on one side. That meaning it could be either, doesn't have to be both, a reactant or a product. All right, so we already looked at one type of reaction that is necessarily a redox, and that's our single displacement, because we said that has an element in it. If we look at this mercury here, mercury oxide, we formed two pure elements. So this one was an oxidation reduction, but the one above it was not. Okay, so we can't say all decompositions are oxidation reduction. Some of them are, but some are not. So I'm going to put some synthesis and decomposition, but not all. And then finally, combustion. And you would recognize a combustion because almost always oxygen is a reactant. Hard to predict the products of a combustion reaction unless you're burning an organic compound. Every time you burn an organic compound, you get carbon dioxide and water. So you can see that sometimes we can name things with a couple of different names. Something can be both single displacement and oxidation reduction. Something can be both synthesis and oxidation reduction and combustion. Okay, so that's why we talk about there are a couple of different ways we can sort out our types of. Okay. All right, questions? These are the solubility rules that are from the book. It's kind of a long table. That's the second part of it, table 4.1. You need to know the ones that have no exceptions.